Now we're going to try to calculate the expected value of the sample mean. So from the table before, we have actually already calculated we found the average of each sample, and we made a table of sampling distribution, which is you make a list of different x bar values and write down the corresponding probability. So like for 2 we have 0.15 as its probability, and for 2.5 we add these 2, and for 3 we add these 3 numbers, and for 3.5 we add these 2, and for 4 we have that. So that's the table we actually constructed right here. So for 2 so we get a corresponding probability for each one. And we want to find the expected value of x bar. If you recall, we had a formula before. How do we calculate the expected value? We multiply the value and its corresponding probability. So 2 times 0.16, and 2.5 times 0.16, and 3 times 0.36, and 3.5 times 0.16, and 4 times 0.116, and we add all those values. So you will get the expected value for x bar. But we also had formulas. We noticed that expected value of x bar is also the same as the population mean. So instead of calculating the expected value for x bar, I can go back to the population distribution. So this is sampling distribution, and the expected value of the sampling distribution, we can use the old formula we did before. So add one more column here, multiply the corresponding values, and add them up. But instead of doing this, it's easier to just calculate the population mean using the population distribution, because this table is the population distribution. You can see there are only 3 rows, and if you look at the sampling distribution, there are like 5 rows. So you have to do 5 different calculations and add them up. So it's a lot easier since population mean is the same as expected value. So why don't I just use this table and I calculate the population mean? And of course the population mean is the same as the calculation formula is the same. So you multiply this value and that value and then add them up. So that's what I do here. So I multiply 2 and 0.4, get a 0.8, and 3 and 0.2, 0.6, 4 and 0.4, I get 1.6, and I add all these values. So 0.8 plus 0.6 plus 1.6, it's equal to 3. That is mu, which we should be, if you use this table to calculate, you should get the same answer. It's going to be the same as 3. So if you multiply them and add them up, you should get 3 too. But again, it's easier just to do the population mean because there are only three different values for the population. Okay, that we found out mu, which is the population mean. So by using this formula, the population mean is the same as the expected value of x bar. So the expected value of x bar, expected value of average, is the same as population mean, which is 3. And actually this works for any sample size. Doesn't matter how many you're gonna pick, how many numbers you're gonna pick. If you're gonna pick 2 numbers, you pick 3 numbers, 4 numbers, 5 numbers, doesn't matter. Even if they say 36 numbers, the sample size is 36, you're still gonna get the same expected value. So the expected value of the sample mean is never gonna change because of the size, but the standard deviation and variance, they change depending on what the sample size is. Because if you can see here in the formula, the variance of the sample mean is going to be population variance divided by the sample size. So the sample size will change. When the sample size changes, the variance of your sample mean will also change. Okay, so let's see. I'm going to also use this formula because it's easier to find the population variance here, so I'm going to use this table again. You only have 3 rows, so I'm going to find the population mean by the formula population variance. Population variance formula is you add all these values, x minus mu squared times f of x, and add them. So we again, as usual, we break down into different steps. So first I do x minus mu. Okay, how do I get x minus mu? It's 2 minus 3. Mu is 3. So 2 minus 3 is -1, and 3 minus 3 is 0, and 4 minus 3 is 1. And then I square each number, so I get 1, 0, 1. And then take each number here, square the numbers, multiply by its corresponding probability. So I take 1, multiply the second column, that's the probability column, 0.4. So 0.4 times 1 is still 0.4. And then I take 0 times 0.2, which is 0, and take 1 times 0.4, I get a 0.4. And I add all these numbers, so 0.4 plus 0 plus 0.4, that's 0.8. That's the variance, but this is population variance. And then how do I find this variance for the sample? This really depends on what your sample size is. So if the sample size is 2, and use the formula here, use the population variance divided by the sample size. So I'm going to take 0.8, that's the population variance, divided by sample size 2, I get a 0.4. But if the sample size is 4, then you have to do the variance of which is going to be equal to the population variance 0.8 divided by the sample size 4, which is 0.2. So if the sample size is 36, you have to use the population variance divided by 36, whatever the sample size is. So the bigger the sample size is, the smaller the variance of the sample mean is. So if you want to, so we're going to always use these formulas to try to find the expected value of sample mean, variance, and the standard deviation of sample mean. And we're not going to try to use the old formulas. You can use the old formulas, but it's going to be very complicated because, so in this case, we only did the sample size 2. If you have a sample size 36, there's no way you can do the old way because you will have picked 36 different numbers you have to pick. So it's a possibility you can get a 2, 2, 2, 2, 2, 2, 2, 2, 2, 36 twos, or maybe a 2, 3, 4, 5, 2, 3, 2, 2, 2, 3, 3, 3, 4, 4, 4, and then you have to do 36 times. There's no way you can do it this way. Okay, so instead of making a list this way, we just rely on the population mean and the population variance. After we find out population mean and population variance, we take them and divide by the size or the square root of the size. Okay, and so that's how we calculate the variance, and how to find the expected value of the sample mean, and how to find the variance of the sample mean.